Welcome, welcome, welcome. Welcome back to my game engine development stream where I sometimes code in front of you and sometimes do it off screen. But still, all the time, making a pretty cool product. Last week, we got very, very close to being done with cleanup code. I've been in the middle of a giant refactor intended to make the engine compatible with hot reloading and play and editor features. We got play and editor working right here inside of the basic editor, which frankly doesn't have a lot going on right now. It's just got a couple of dummy menus and buttons and things. But now it's got the ability to play. And if we were to go and close the project and reopen it, it'll actually unload and reload the DLL. But there's some quirks. So for starters, I just reloaded the game project. And you'll notice that Mr. Hollow Knight here is covered up by Madeline from Celeste. And yeah, and it's even money that the other sprite is doubled up as well. And in fact, I had used RenderDoc and confirmed that every time I go to reload the project, the scene entities populate twice. Now is not quite the time to deal with that. We'll get there. Because like play and editor, the idea is that you're playing inside of the scene that you're editing. So technically the when you go to reload a game project or a game module, that's not the time to clear the entities from the scene. But we'll come back to that as we need to. For now, I'm gonna finally tackle one of the hardest things to deal with cleanup, and that's gonna be the shader code. This is something that I started to look at a couple of the streams back, like I think almost a week ago, and I just wound up putting it off because it was easier to do the other stuff. But I had a good relaxing weekend. I got some sleep. I just had a tasty donut from the local patisserie, and I think I'm gonna give it a shot now. So for starters, where did we leave off on this file? I don't think I kept any of the changes that I started off with on this file. So let's take a look at the git diff. So it looks like we added the runtime.h. I commented them out, but I added trackers for includes in program and include ref counts, which has to do with shader loading or shader header loading and unloading. A comment that says check the program has not been compiled before, so that's going to be reference counting stuff. I'm actually going to take that comment out because I'm going to need to review all of these scenarios anyway. Yeah, and then I had another section where I started to do reference counting code that I'm also going to clear that out and start over because I don't really remember what my plan was. And that leaves us with the very, very bottom. We have a editor play cleanup shaders call, which is totally fine. That's the code that we're going to worry the most about today. Awesome. So let's make a list of things we need to do. I'm a huge fan of lists. There we go. So there's a handful of things that haven't been set up that I kind of need to do now. The first is that I need to do reference counts for include files. So as it was, originally whenever I had somebody load a shader file, so if we go to test state, for example, which has got the code that we were playing with before, I'll load it up in the launcher real quick just to make clear what we're looking at. Let's have it recompile. Give it a second. Come on. There we go. Yeah, so this basic scene, these two sprites are loaded up from a scene file. The text and the overlay on the top right, those are loaded up via just via the state code. So that's all encapsulated in here. But we load up shaders. EP graphics, shader, data type. Oh, that's interesting. Do we do graphics, load? At some point we load up, and there it is. So if we invoke load shader file on a GLSL file, so let's take a look at simple material, for example. Simple material.glsl. You can include GLSL headers that will provide you helpers for various things, and I plan to use this to a great extent on systems. The way that the shader parser currently works is that you include a header file once, and then that is just read and loaded and stored into memory and kept there and cached there for all future shader recompilings. And that is a perfectly fine way to do it, except for now we live in an editor environment, and the editor needs the ability to unload these things. So we need to get it set up so that whenever we invoke load shader file and then we delete a shader program later on using, I think it's EP graphics delete shader. Whenever we go to delete a shader program, it'll decrease the reference count for the headers inside of it. And then once those references hit 0, they'll just simply unload. So that's probably the first thing we need to worry about. And then following that, we need to start tracking any shaders compiled during play in editor. So if we do load up a test state like this one, we need to make sure that we track every single loaded shader, so that way even if the game code forgets to delete it, then we can call delete on the shaders for them, for the developer. And then lastly, we need to unload all shaders during project unload. So that way, when you go to close out of a project, even if you have a game system such as a 2D or 3D renderer that keeps its shaders loaded during play in editor, we want to first keep those around after play in editor finishes, and then second, we need to make sure that they get cleaned up correctly even if the developer forgets to do it. Now there's a few more things on top of this very basic list. I think that we'd be lucky to get all of these done in the next couple of hours before I have to get off stream. But there was another thing. I'm trying to remember what it was. Let's go back to the resetables list. Graphics, shaders, compiled, loaded, includes loaded. Actually, I don't think it's part of this list, but it's important. We need the ability to reload shaders. And this seems a little simple, but it's something that we've kind of skipped until now. The way that up until this point, the way that we've been handling load shader calls is that if there's more than one place in your code that references the same shader, then we check to see whether, when you call a load shader file, we check to see whether that's already been loaded. And if it has been, then we don't bother compiling it again. What we do is we simply increase its reference count and then return the handle to the program that was compiled. So that's great for a shipping game, but now we're in an environment we're going to have to do like live looped reloaded code. We're going to need to be able to make a change to the shaders and then load them back in. There's a couple ways we can do this. We could watch file for changes. So if we go to load up a shader file, we can detect whether the file has changed from last time. And then if it has, then we actually go through the recompilation. If it hasn't, then we just continue with the old way of doing it, where we just increase the reference count. We could also, I'll start using the word or at the end of these. We could also simply have an alternate API. So we would say like load shader file, and we would do the path like normal. And then we would have an optional bool for whether we want that shader to reload from file or whether we want to just reference count. That's an alternative way to do it. So that way, like, you would normally just say, oh, I want to load the shader up and use it. But if we are in the editor, we can also say, okay, pass true to say, we'll actually also recompile no matter what the reference count is. So there's a couple of different ways you could write that, so I'm just going to use the terminology alternate API. And then there's the choice to have the editor always reload, or editor and launcher always reloads. So this means that in a shipping game, we just use reference counting because you're not going to be changing shaders on the fly in a shipping game. But if you're in the editor or the launcher, whenever you go to load the shader file, it actually goes through all the hoops and reloads it. If we were to do that, I think this is probably just a bad idea. This one, because in this situation, if you have a whole bunch of places that use the same shader file in your code, then the game will hang for a moment while it recompiles the shader every time. So I'm leaning towards idea 1 or 2, which is that we either just watch the file for changes, or that we use an alternative API. The first one has the advantage that we could conditionally compile this. So that way it only will watch for GLSL file changes if we are in the launcher or the editor. Because again, in a shipping game, you're not going to be changing the GLSL files. You're just going to be doing that when you launch when you go to reload your code, basically. But also, there's an advantage to using alternative API, because what we could do, there's actually a few different forms. There's the form we already talked about. We have like optional bool in the shader file, where we can pass in whether we want the reload to be retriggered. We could also do like a load shader file always recompile, or just like recompile. That's going to be like editor only. So you have a call that the editor or the launcher can make where it invokes load shader file recompile, and it'll reload the file always, rather than just doing the reference count increase. However, there's also the possibility that we just ask the editor to reload all. Where basically the editor can just request that every shader that's been compiled gets recompiled. I'm not liking that very much. So I think watching for file changes is probably a good way to do it. I think that's probably where we'll go. But this is all kind of secondary to the first three things, which is that first we actually need a system for clearing out include files when they're no longer in use, and then we need a system for unloading any shaders that were created during Play in Editor. Right. Okay. And this is the test state code. That's the simple material shader, and here we are in shaders.cpp. All right, cool. So we already do have a method by which we track the reference counts for shaders. We just don't have it set up for includes. So I'm going to do that here. It's basically just a map. You pass in the hash name of the include path, and then it gives you back the number of references it has. And then includes in program. Yeah, this is also important. So the ref count will tell us how many references a include file has. This map includes in program will tell us the list of includes that a program that a shader program has loaded, and we have to keep that list so that we know which reference counts to look up. And the key is going to be the program name, and then in this one the key is going to be path to header. Cool. Gonna try and keep my throat from going out while I'm working on stream today. I usually wind up pretty raw by the end. Okay, so let's find the spot in code where we load a include file. So I think there's a helper function for this, but I'm gonna actually, I'm going to Control F the place where we actually store the text. So that's include source buffers is a map associating the hash name of the path of the include file and its data. And basically when we go to assemble a GLSL file, OpenGL accepts pointers and string lengths for its segments of a program. So basically we just pass in a whole bunch of pointers to the correct locations within the buffer for that header, and how long each should be. That's what these two are for. So let's go and find where we use this. So we have a parse include file. And we start by pushing back the pointer to the first character inside of include source buffers. So this is where we first start to populate the include buffer, but it's actually not where we load up the contents of the buffer. So let's keep searching. Okay, this is, I think, where we're looking for. So we're inside of the compile shader source method. So this is the GLSL preprocessor Enterprise uses. And at this point, we are checking whether the include path is a valid key into include source buffers. Essentially, we're checking to see whether the include file has been loaded before. If it has, then we skip this code and move on to setting up the rest, which tells me that this is where we want to do our reference counting. The next thing we do is we check to see whether the include file exists. If it doesn't, then we issue a warning that the include file doesn't exist, and we'll move on. It's still possible that at this point, it's still possible that the GLSL file will finish compiling correctly. So we don't actually break anything here. We worry about damage control only when the program fails to validate. In which case, we won't have populated anything in the include buffer anyway, so this is all fine. And in here, assuming that the file exists, we load the text, and then here we go. We load the text file into include source buffers, so this is where we actually populate it. If there's a problem, then we wipe out that element from include source buffers, issue a warning, and then continue parsing. Okay, cool. So at this point, this code block is where we want to do the reference counting stuff. It looks like. So what we're going to do is we're going to go to includes in program, and we're going to pass in the hash of the file, or sorry, of the program. Do we not have a At this point we should have parsed out what the program name is, because in my spec for enterprise shader files, we require that the first thing is the EP shader line, which tells you excuse me, which tells you the name of the shader. So here it is, shader hash name. So we will insert an element at shader hash name, and remember that this is a vector of hash names. So we will say dot pushback, and the thing that we're going to be pushing back is the hash of the include path. So that will be this guy. Right? Cool. So at this point, in the compilation, right before we actually handle loading the include file, actually parsing the contents of an include file, we add a reference to it to includes in program. So let's go down to the bottom of all this. We're going to need to find the code that handles failure at this point. So that would be maybe hard to spot. Okay, so this is where we integrate the include file into the shader source buffers. So basically, we start inserting pointers to the buffer containing the include file source. It's a little complicated to go over how this all works, but it's important. And this is importantly, this section here cannot fail. There's no failure condition. So we can scroll right past it. And it looks like we can kind of scroll past all of this. Got a number of warnings for situations where you accidentally put something unexpected after vertex. This is referring to how you can specify a section to be for your vertex shader and a section to be for your fragment shader. Okay, and actually, yeah, it's looking like we can just skip all of the rest of the pre-processing code, because all of the failure states of the rest of the source code after we get to the first vertex section, all of those states are checked not during pre-processing but during compilation, where we actually tell OpenGL, here's the source code, please give me a program. Here we go. Yeah, so this is where we do it. Variant compilation. So the first thing we do is we calculate how many variants there are. This has to do with how many... this is basically combinatorics with the pragma option statement, which this file doesn't show. But you can specify a option that you want to enable or disable. And for every option you give it, it'll branch off another variant of the shader program. On really, really, really big titles, this could lead to some crazy large numbers of shader programs, but we probably won't ever hit that limit. If we do, we're going to be having ways to get around that problem, like recompiling, cache compiles, and reference counting through profiling. Okay, and here's where we actually assemble the stuff that we pass to OpenGL. So we assemble a string out buffer, and we have dynamically sized arrays for the uniform list indices, block indices, and stuff that we use from the introspection, where we get the names of everything that's in the program. This is where we take all the characters out of the buffers and we populate, we assemble what the variant program looks like. It looks complicated, it's just wordy is all. It's not horribly complicated. And it would take time to explain. Okay, here we go. So we pass in the... First we check to see whether or not a particular variant exists. If it doesn't already, then we will create a shader object for the vertex and fragment shaders. We pass in the vertex and fragment source code. We compile vertex, so we use GL compile shader for that. And we check to see whether the shader compiled successfully. If it failed, then we have a condition where we need to clean up after ourselves. What's the game doing on the music? Okay, it's looking good. I recently rejiggered my audio settings to make sure that my loudness was comparable to other Twitch channels. But I find myself having to turn down the music for me to think. But that's a me problem. Okay, here we go. So we have an OpenGL Vertex shader compilation failure. We print out the source code that failed to compile, so that way we can see very clearly what the issue was, because it's not always obvious when you're looking at the actual GLSL file how a pragma option might lead to a failed compilation. And at this point, we delete the shader. Yep. We don't have to delete the fragment shader yet because we haven't even gotten to that point. We set return val to false, and then we hit continue. And continue, what does continue do in this case? I'm looking for the outer for loop that this continue call invokes. Okay, so we continue on to the next shader variant in that case. Okay, cool. But we do set return val to false, so I'm wondering. Okay. So having one variant fail compilation is enough to continue, but it does try to compile. It does try to compile the other variants. So technically we haven't actually hit our fail state yet. Here's where we actually link the program variant. So kind of like in C++, how you compile objects and then you link those together into your executable. In OpenGL, you compile shaders. They call them shaders, which are just parts of the pipeline. And then you link those together into a shader program, which is what you conventionally think of as a shader. And that represents the whole pipeline state. The whole pipeline program, I should say. You can change the state using uniform buffers and things. Okay, so here's where we actually store the program. So this makes sense that this is where we would increment the reference count, include ref counts for include ref counts for every single include used by this program. But we are still looking at this on a per variant basis, so actually we should move on and do this later, farther down the chain. So this is all the introspection stuff. We identify all of the things that we can bind to inside of the shader program, and we do this once for every variant of a shader. Okay, and then this is out here where we are done. So what we need to do here is, at this point, we have compiled all of the shader programs associated with the shader file. We will have pushed back the during the pre-processing step. We will have pushed back every include excuse me, every include path required by the shader program. But we haven't actually increased the ref counts because there's a possibility that we would need to delete that data down here. And this is where we would do it. We would say if return val is false. This means that there was a failure at some point. We would erase the data that we had pumped into the includes in program. So we would say dot erase, and we would pass in the hash of the shader name. So it'd be shader hash name, I believe. There it is. Is the value? Cool. But on the other hand, we do actually want to, if it's possible, what we want to do is we want to increase the reference count from here. And I don't think there's a problem with doing that. If I followed everything that I just read, which is 2,000 lines of code, if I'm following that correctly, I believe that we can do include ref counts at shader hash name ++ and increase its ref count. Because up until this point, we haven't actually touched the this map, so its key doesn't exist yet, so we don't need to worry about clearing it if there was a compilation failure. So I think that's it. We've got the reference counts in the right places. During pre-processing, we will track which includes are required by a program, and in the end, after we have gone through all the compilation and linking, if there was a shader variant that failed to compile, we will not increase the ref count. There's two gotchas that I have in mind that I gotta double check. The first is that if there's a failure to compile a shader or a shader variant, I gotta quickly double check that we actually go through the process of deleting all of the other variants. So there's 3 failure states that we can reach. The first would be down here, where we are compiling the vertex shader. The second is when we are compiling the fragment shader, and the third is when we go to link. Right? Yeah, link program. This stuff right here. So if we do fail, do we actually go through all of the others and delete them? I think I might have an oversight here. Alright, so at this point, we create the program, we attach the shaders to it, we link it, we detach the shaders, and at that point we can delete these shader objects themselves, because we only needed them up until the point we went to link the program together. We then check the compilation result, which in this case is a linking step result. And if it's false, we get the error message, display it, delete the program, erase the program from OGL shader programs. Oh, hang on. Variant map. Okay, so I think there's an oversight right here that I need to worry about. So at this point, we have identified that there was a failure to link a variant of the shader. we display the message, we delete the program. That's all good. But at this point, we've got any other variants that were part of the GLSL file. Any of those are still potentially viable. And what I'm doing here is I'm leaving them compiled and in OpenGL's memory, but I'm deleting my handle to them. And that's bad. So there's two ways I could handle this. The first would be to delete all shaders, shader variants, which means actually going through and saying GL delete program on every element of GL shader programs under the shader hashname key. Or I could delete just this one and handle missing variants when they come up. And I kind of like that option a little bit better, because if you make a shader program and you screw up the code in such a way that it only affects a single variant, it would make sense for only those variants to fail to bind, so that when you're looking at the game in the editor or in the launcher, you'll see the magenta color, the null shader pop up on only the objects using a particular variant of a shader, and then the rest of them will still work correctly. So I think that's what we will implement here. And we actually have to implement this in 3 places at each of the 3 compilation failure points. So at this point, we've already deleted the program. We just need to erase the one element. Instead of the entire list of them. So in this case, I'm using a variant map which accepts it accepts the hash name of the shader as the first key. The second key it accepts is I think it's a tuple, or is it a vector? I can't quite remember. Basically, it's a key representing the combination of shader options that access that variant. And then you get your program out the other side. So we'll say if OGL shader programs so what this is doing is it's only deleting the OGL shader programs key if there's nothing in it. Which I suppose makes sense. But where do we insert it? So prior to introspection, which is where we get all of the data out of the compiled and linked program, we will assign OGL shader programs. We'll assign the variant to OGL shader programs at the shader hash name and the variant lookup key. So actually, it looks like our old code, maybe I just misread the situation. It looks like the old code actually allows for the possibility of skipping over a particular variant. Okay, so actually what'll happen is it'll mark return val as false if there's a problem. It won't store the program that failed to compile, then it'll move on to compiling the next one. That is actually perfect. That's exactly what I wanted it to do. I just had to double check that it was actually doing that. So if that is what it's doing, I should update the documentation for this. So let's go to graphics.h. We'll find the call for compile shader source here. We should say it simply says true if it's successful, false if unsuccessful. But that's not exactly accurate. I'll say true if all shader variants compile successfully. Otherwise, false. And that's more correct. The idea is that if we get a false out of compile shader source, then if we get a false out of compile shader source, the other variants that didn't fail to compile may still be viable. So I guess the next thing to check, given that I had bad documentation on these calls, the next thing to check is to see if we use their return values incorrectly anywhere. Okay, so here's where we use the return value. So if we go to specify a shader file path, we load the text into a buffer and we pass that into compile shader source. And if that returns false, then we will set current shader source path to null and then return false. Actually, we set current shader source path to null anyway, so that's fine. This is just for tracking within compile shader source what the path is. And then we return an error message, or we present an error message. That's fine. I should say graphics load shader file. Yeah, that strikes me as unnecessary. This code basically just checks to see whether or not compile shader source returns false, and if it does, then we present an error. And we could totally do that in compile shader source itself. So this is where we do the error reporting for the shader itself. I think what I was thinking when I wrote this code originally was that in addition to knowing where the code went wrong, you would also want to know the path to the file, and compile shader source handles both hard-coded GLSL, so stuff that you put in your CPP files as raw strings, and GLSL loaded from file. So I was thinking probably that we wouldn't necessarily know what the path is from here, and that is true, except I do have a way to get it. So I'm going to say if current shader source path is not equal to hashname null, then we will present the message from here. We'll say graphics compile shader source. Somebody's mowing their lawn outside. Hopefully that's not just not bleeding into the audio. Graphics compile shader source, affected shader path, and then we have pass in hash name to string current shader source path. Oops. Like that. All right. Normally I would be using Alt-Shift-F to be reformatting this using Clang format as I go, but this is an unusual file in that the pre-processing code takes a huge amount of width, and it breaks my 90 character width limit pretty handily. So I think what I'm going to do is I'm going to come back to this file and format it at the end, temporarily overriding my column limit to be like 120 characters or something. In fact, let's do that now. I'll go to Clang format. There's my column limit. I'll change it to 120 characters. Control save, and then Alt Shift F. And hopefully I didn't just break a whole bunch of things. I made a number of changes. And actually, now that I'm thinking about it, this code where we actually tell it what path was affected, that could probably go at the very end after every single variant has been compiled. Down here. So if return val is false, then we will pass out the affected shader path. Oh, that's weird. I just tried to format these characters and then nothing happened. Huh. Okay, I'll come back to that. And now at the end of all of the compilation, we'll see all of the individual warnings for each of the variants that have problems. We'll see their reasons why, and then we'll say that the affected shader path was this. That's good. And then let's remove that code from load shader file. Here it is, load shader file. And then we just need to have, we'll say bool return val equals compile shader source. Current shader source path equals hashname null. And then we just return val like that. Cool. Awesome. Now heading back up to the end of the compile shader source, here. Now understanding that return val being false only means that one of the shaders, one of the shader variants failed to compile. We need to handle reference counting a little differently. Cleanup to make this a little bit more clear. So this error message here will be presented if one of the shaders fail to compile. And to make this a little bit more clear, instead of just doing return val, I'm going to title this all variants compiled successfully, or make that a little shorter, all variants successful. Yep. Now we need to have a different means by which we identify whether no variants were successful. So one way to do that would be if we go into the program map, OGL shader programs, we can look up OGL shader programs at shader hashname. We can do .count. Actually, what we can do is we can do .count on the shader hashname itself. So if there's an element at OGL shader programs shader hashname, then that means that because up here we were deleting before introspection, we were carefully deleting every single empty element. OGL shader programs, if its array is 0 and in point of failure, then we just erase its element. If there's anything at all inside of that key, then we know that one shader compiled successfully. And in that case, we will increase the ref count. Otherwise, no variants were successful. Yeah. And then we don't, not only do we not increase the ref count at that point, we do need to erase the list of includes referenced by this program, because we've been populating this during the pre-processing code. Okay. I think that's everything. There was another gotcha that I had my eye on earlier, and I can't quite remember what it was now. So I think that's it. I think we'll just leave it at that. So now we have, and it took a lot of parsing, a lot of code parsing to identify every situation. But now we have a system that will track reference counts for the include files as we compile shaders. We're going to need now to decrement those reference counts when we go to delete a shader program. So let's take a look at that. This is the delete shader method. We pass in not the path, but the name of the program. And then we have a early return warning if we try to delete a shader that isn't loaded right now. If it is loaded, then we decrement its reference count. And then if the shader reference count hits 0, then we will unload that shader. So we go in and we say GL delete program on all of the programs inside of OGL shader programs program, and then we erase the elements from our internal tracking. And then we unbind the shader if necessary. We say if active shader name is equal to program, then we set the active program back to EP null shader and assign it. So I guess this is the place where we would decrement the include reference count. Include ref counts at program minus. Oh wait, that's not right. I need to loop through every single include reference inside of this program. So we're going to need to do for should be a hash name ref, make it const. For every const hash name reference, we'll call this include. Includes in program, passing in the program name. We will decrement its reference count. So it'd be include ref counts at include minus minus. And now if the ref count is equal to 0, or I should say less than or equal to 0 to be more secure. Then we need to unload the include, which we haven't had to do before, so we're going to need to come up with that code now. Before I do, though, something strikes me as weird about this code right here, where we go to unbind the shader program, because I don't actually see an OpenGL call here. All I do is I see updating my reference lists to use the EP null shader. And it makes me wonder whether I need to actually call the bind on it. Bind shader. Yeah, so I'm missing a call here to GL use program. So in the actual bind shader code, I have to do a number of things besides simply binding the shader. We also have to make sure that all of the uniform buffer blocks are bound correctly. So we have to confirm that the shader that we're trying to bind is compatible with the current shader options. And if it's not, then we call GL use program. I didn't do that in this code here, so let me do that. So if we go to delete a shader, and if it was the active shader and it's the last reference to it, then we need to set active shader name to EP null shader. Tell the OpenGL side that we are now using EP null shader with no options, and we invoke GL use program on it. So that way, if for some reason we try to render without binding to another program, then we will be actually using EP null shader. Alright, cool. Making progress. So when we go to unload the include, there's a handful of things we need to track. It would actually be every single one of these we need to clear. Yeah, so what I did is I just copied all of the state that's defined at the top, heading back to the delete shader call here, pasting it into the section where we're cleaning up, and then just using this list as reference as I go to clean up everything. Okay. And in this case, key includes in program name. That's something we'll clear after this block. So we'll say includes in program dot erase program, like that. Same thing for include ref counts. We'll do dot erase, or sorry, not erase, dot clear. No, dot erase on program. On include. Oh, hang on. That would be something we do in here. So inside of the loop, includes in program for every include. We would do include ref counts minus minus. Yeah, so I would do this up here. Like that. And then we got the buffers, strings, lengths, pragma option string positions, pragma option string lengths, pragma option string name indices, pragma option string insertion points. So all of these are state used to construct a shader program using this header. And we can simply call erase on all of them using the include hash name, which is the hash of the path to the include file. Use that as the key. Okay, I think that's that. And unlike when we go to unload a shader or whatever, like a regular shader object, we don't actually have to call OpenGL code here because includes are basically just text that we insert into any given shader. So all of the shaders that reference this have already been deleted, or the last is about to be deleted. No, it's already been deleted. And then when we go to clear out this text, simply we were just making way for new text the next time we go to load this include file. So I think that's that for include reference counting. Yeah. And then after that's done, we're going to track play in editor compiled shaders. Let's first confirm that this compiled. looks like it's going to take a minute. Okay, and that's looking like it's finished compiling, so it seems to be working correctly, or it seems to be compiling correctly. So I'm going to now confirm that nothing breaks when we go to unload shaders. So I'm going to do this from the test state, which is the code that runs when we use Plane Editor. Because inside of it, we take advantage of shaders. Here we go. So in the init call, we load 4 shaders. We load simple material, simple MSDF, depth render, and post process. We only use simple material and simple MSDF. But up until now, we've just been allowing those references to increase. So now what I'm going to do is, instead of loading shader file on these, I'm going to say delete shader. And we're going to be passing in the hash name of the program itself, which I believe is simple material. I think these are all the same names as the files themselves, but let me double check. So simple material is simple material, that's right. Oops. Simple MSDF is simple MSDF, that's right. Depth render, oops. Depth render.glsl is depth render, that's right. And then post process, do I still have that? I do. Okay, this is the simple where I do sinusoidal wavy shit in the post process. That's the same name as well. All right, cool. Let's compile, because this is a much faster compile because it's only the one object. And then let's run in the game. So this is running through the launcher, so we're not actually reloading here yet, but quitting doesn't crash, so that's, very basic, but needs to happen. Now we have the editor loaded up. I hit play. We've got Plane Editor going. And now what's different in the editor is that when I go to hit stop, test state has been destroyed. So we've now invoked delete shader on all of those shaders that we had loaded. I hit play again, and we got a problem. What's that? Is shader viable? No shader program exists with the provided hash name, program simple material. That's interesting. So I've deleted it, but there's a reference that's still using it. Where are we in the call stack? So we're in state manager.draw, test state.draw. All right, that's interesting. It's as if the init code is not reloading the shader files. So there's a problem there. I don't actually have any other warnings in the console. So this doesn't seem like it's related to the code that I've been using so far. This is probably just another area in which I have not tested. So here's what I'm going to do. I'm going to set a breakpoint on the load call, I'm going to set a breakpoint on the delete call. And then we're going to confirm that everything gets reinitialized before the next draw. So here we are. I hit play. We hit the load calls, so that's loaded up those shaders. And now we've got the program running in the window. I hit stop. The delete call is invoked. That's everything's correct, and now the plan editor is finished. If I hit play, we do invoke load shader file on the file again. So let's step in and see what could be going wrong. Okay. So we've got the current shader source path. Let's jump into the compile shader source. And this is the GLSL preprocessor, so this is going to be a little complicated, probably. We're initializing all of our parser state. Okay. And then we're looking for the EP shader directive. So on the watch window on the left, I'm watching the line, which is a string view, I believe. Yeah, it's a string view of the line that we're inspecting. Currently, we're on the EP shader simple material line. So now we are in switch case 1, looking for the shader name immediately after hashtag EP shader. Okay, and now we've identified simple material as the shader name. Now, interestingly, there is still a reference to one of the shader programs at this point. I'm willing to bet that that's the null shader. I'm gonna check that out. Hash name to string. Yeah, EP null shader. So I'm inspecting the shader reference count map. There's actually a key still for every single shader program so far, so I'm not erasing those correctly. Let me jot that down. But the shader reference count for simple material is still 0. So it looks like what we're doing here is we identify that there's not a key yet. So what we do is we add the key and we increment its count. Oh, okay, so that's what's happening. So I'm taking, my code assumes that the reference count key is missing from this map by the time we get here. And if it is, or if it isn't missing, then it assumes that we've compiled before, even though the reference count may still be 0. Okay, so that's gotta change. Let's figure that out. Stop. So down in the delete call, delete shader, here we go. If shader ref count for the program is less than or equal to 0, then we go through all of this. Then we gotta say shader ref count dot erase for, what's the name of the program? Okay, and at this point, the key will go missing, so that way when we're loading the shader again for the first time after, then we will correctly identify that it hasn't been loaded, or that it's been unloaded. All right, cool. Turning off my breakpoints, F7 to compile. Cool. F5 to run. Play. Works just like it did before. Stop. Play. Aha. Okay, cool. So now we are back up and running. That cleanup code seems to be working great. I just hit start and stop several times at this point. So what I'm going to do is I'm going to set a breakpoint back up in, I don't know, somewhere. I want to inspect the tracking state for all the stuff that we've loaded and unloaded, just to make sure there's no memory leaks. So let's do load shader file. I'll set a breakpoint. And then I will stop and play again. And my breakpoint's been hit. And now we can inspect. Let's inspect the reference count maps up here. So at this point, we only have the one key for the null shader, and it's got a reference count of 1, and that's good. We always have a reference count of 1 for the null shader because it's loaded up by the runtime. So that way it's always loaded and never unloaded. Where's the include reference counts? All right, and the include reference counts. On the include reference counts, we appear to have an issue. I'm looking at each of these, and I'm seeing 66166. So there's 6 references at this point, even though we are still just now loading up these other programs. Let me look at includes in program. So includes in program for EP null shader has only one reference that it cares about, and that should be the enterprise.glsl, the universal header. Which, yeah, that appears to be correct. It says engine/include glsl/enterprise.glsl. So that's the header that should always have one reference, because that reference is always the EP null shader, at least. However, if we take a look at includes include ref counts, we have these other references with a whole bunch of stuff in them. So let's translate what these say. So simple MSDF at this point has 6 references. And then what's this one? EP Null Shader has 1 reference. So that's interesting. Why does EP Null Shader have a reference in include ref counts? Because it's not an include file. Wonder how that happened. Alright, so we've got a problem here. There's a memory leak somehow. Every time I go to stop and restart, we have references remaining. I'm going to take a quick break, and then when I come back, we're going to hunt that down and fix it, so that way the includes do properly get erased when we stop Plane Editor. And then once we know that that stuff is working, we'll get to tracking the programs that are loaded during Plane Editor, so that way we can ensure that they're cleaned up even if a game developer forgets to do it themselves. Be back in like, I don't know, 5-10 minutes probably. Just need to get some more water. I'm back with some water. By water, I of course mean coffee. Even though it's noon where I'm at. But like I need to. Okay. Alright, and how's my audio levels doing? Yeah, good. Good. Cool. So, where we last left off, we had gotten reference counting implemented. However, we are still seeing some memory leaks regarding the include reference counts. So, all the include stuff, if we take a look at the include buffers, where's the include source buffers? Oh, that's interesting. So actually, the include source buffers are being deleted correctly if we take a look. Because if I inspect include source buffers at this point, it's only got the one element. That element being the source code for enterprise.glsl. And that holds true for the rest too. Include source strings has only got the one element. Include source lengths has only got the one element. But in the case of ref counts, there's still a whole bunch. So how come that's not being cleared? Yeah, it includes in program as well. It's only got the one program. It's only got the one element in it. So that's the null shader referencing enterprise.glsl. Yeah, so I guess it's just this one map that's not being cleared. Let's head down to delete shaders. Delete shader. Okay, so let's walk through this. We're deleting a program. We reduce its ref count. As soon as we identify that it's hit 0 and we need to unload that shader, we'll go through, delete the program. We'll clear out all the stuff that it cares about. And then we will go through every single include referenced by that program. We will then decrement the ref count for that include. And then if it's less than or equal to 0, we will include buffers, strings, lengths. We'll erase all that stuff, buffers, strings, lengths, all of the data. And then we will erase include ref counts. Actually, this could be outside. I don't think that actually matters for execution, but we can call erase. No, it does. I need to have that inside. So only if we're less than 0 will we remove that key. So for some reason, this is not being triggered for every include file. So I'm going to stop execution. I'm going to set a breakpoint here on the include ref counts dot erase line. And try and figure out why it's skipping over it. So I hit. Let me get rid of that breakpoint. Continue. So we've just started playing editor. So we've loaded those 4 shaders for the first time. we go to stop, and we're looking at include ref counts.erase. The element that we're erasing has got a -1 ref count. How did that happen? Oh, okay. It happened because this is a program that didn't include. Huh. So we're going through every include referenced by which program? Simple material, it looks like. Which was apparently linked to batchshaders.glsl. But include ref counts didn't track that reference. Oh, hang on. Yeah, I screwed up. All right. So up here where we're tracking the reference counts for the includes, I've been passing in the wrong key. So includes in program takes the key for the shader hash name. In this case, I need to actually get every include from includes in program. All right, I got it. I can change the music up. I'm getting a little bored of this one. Do some more Celeste. There we go. Yeah, so instead of directly incrementing, we have to actually get every includes in program element and then increase those ref counts. So we'll say for every const hash name reference include in includes in program shader hash name, like that. We will say include ref count at include plus plus. There we go. Perfect. I think that's probably it. So we'll hit F7. We will try this out again. Cool. F5. Hit play. Hit stop, hit play, hit stop, hit play. Cool. Let me do that like a bajillion more times. Okay. Awesome. And now let's set a breakpoint somewhere. Load shader file. Actually, compile shader source. Let's do that. Okay, set a breakpoint at the start of compile shader source. Back in the editor, I will stop. That should unload all the stuff. So at this point, yeah, at this point we should have the EP null shader loaded, and I think that's about it. Let me hit play. And now let's take a look at the state. So select a shader name. Is what again? Simple MSDF. Select shader options. Active shader name. Fallback shader. Okay. Shader ref count. We've got one element. That's the EP null shader, and it's got one reference. That's good. Shader source paths still has elements for every single shader. Okay, let me put that in the list. Oops. Shader source paths still has deleted elements. Okay, OGL shader programs, we've only got the one reference. And that is EP null shader, yeah. Yeah. Shader attrib locations, blah, 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 blah. These are all looking good. Shader sampler type. It's got a number of elements in it that I wasn't expecting. So shader sampler type is a shader variant map, meaning that it accepts the shader key, the shader name as the key, and then the shader options, the active shader options, as a second key. There's a map for every variant associating the name of a sampler with the name of a or the type of the sampler, so that way we can correctly track whether a texture can be bound to a specific sampler. And there's an element for a number of shader names, so that's not good. I'm expanding it in the watch window. So which one is this first one? For starters, simple MSDF. Yeah, so this is another thing that's failing to unload. Let me put that in the list. Okay. Same thing goes for OGL shader sampler locations. And uniform block sizes for some reason. Okay. However, it looks like the include reference counting is working great because we only have enterprise.glsl loaded. Okay, so we're nearly there then. We just have these 4 elements that we need to worry about the reference counting for. Otherwise, I mean, technically speaking, everything is working just fine. It's just that we don't want that memory to continue to swell up every time you start and stop, because it's totally possible for that to become an unmanageable mess while you're working. You just have it's a fairly slow memory leak right now, but it might quicken depending on the game you're working on. So let's figure those things out. First was the shader source paths, which is not being cleared when the reference count hits 0. So let's look for shader ref count dot erase. So that occurs here. Delete shader. We go through we do a reference decrement on the shader handle. We call gl delete program. We delete all the includes. Yeah, so it looks like we just never got around to erasing shader source paths for this program. I'll put this down next to shader ref count. So I'll add some comments to make this a little clearer. Unbind shader if bound. Unload includes if last reference, and yeah, I'll add a comment. Might be a little much on the comments, but delete program, delete OGL tracking, and that's probably where these come in. Shader, yeah, so here we've got shader sampler type, shader sampler locations, and uniform block sizes. Not clearing. Let's head to the OGL.h, OpenGL.h, because there's a question at the back of my head regarding whether these items are utilized somewhere else. Like maybe I need for the sake of uniform blocks, maybe I need to not clear those elements. Because separate to the shader programs, you can create a uniform buffer, and that would define a uniform block size, I believe. Let's go to uniformbuffers.cpp, uniform block names, block binding points. Uniform block sizes is not referenced in here, so I guess that's not it. How about shader sampler locations? It's referenced in textures.cpp. Okay, and where it is used, it does potentially insert subkeys into the map, but I'm not gonna stress over that. How about shader sampler type? It's also used in textures.cpp, and its usage is similar. It'll do a check for contents, inserting an empty key if the key doesn't already exist. But that's probably fine for the sake of readable code using these map types. Shader source paths is probably only used within the file. Yeah. Okay, I'm satisfied. So inside of the OpenGL tracking stuff, we can delete all of these. So let's do that. Okay, so there's programs, there's attributes. Attribute, shader attribute, sampler type, locations, uniform block sizes. Yeah, all right, so we can just call dot delete, dot erase on all of these. Program. And that should be the end of it. OPGL has no member uniform block sizes, don't you? Where did I see you? Okay, so yeah, you needed to be changed, but I guess you weren't part of the OpenGL namespace. Okay. Okay, I think that's probably the last of it then. F7 to compile. Take a sip of my coffee. Cool, F5. Let's do play and stop a few more times. Okay, cool, just like before, it's not breaking anything. That's the very baseline. But we care about memory leaks here, so I've done this a number of times. Let's stop again, and then go to compile shader source, set a breakpoint, and then do this again. Wait, it's already running. Hit play, it hits the breakpoint. Now I can analyze the state before the first shader program is recompiled. Go to OGL shader programs, has only one element. Same with the attrib locations. Same with the attrib array lengths. Sampler type. OGL shader sampler type has only got. It actually doesn't have any, because the shader in question, null shader, doesn't have any samplers in it. Same thing goes for shader sampler locations. Uniform block sizes. Uniform block sizes. We have 3 uniform blocks. That's right. No, we have 3 uniform blocks in EP null shader because EP null shader, while being a null shader, has access to everything that's global. So it has access to the time uniform buffer, which tells you what time it is in the shader. It has access to the per draw and the per camera stuff for transformation matrices and things. Okay. We've only got to include, or enterprise.glsl is the include. Source strings. Yeah, perfect. Yeah. Yeah. Okay, I think we're there. Hopefully. Yeah, that's it. Okay, cool. So just to be extra sure, I'm going to step over one more. I'm going to confirm that these are actually increasing their counts as I load more programs, and they are. We're now getting more and more programs and include buffers as we compile the shaders that need them. Yep, and all of the include source buffers are unique. And we take a look at their reference counts. They are all size 1. That is sweet. Cool. So that's goal number 1 taken care of. Reference counts for include files. Cool. So now we know that we can correctly load and unload shaders during runtime, and it will wipe all of the memory associated with the shaders and the include files as needed without loading all the include files multiple times. We use a reference count system for that. So now we need to reach goal number 2, which is to automatically unload any shaders compiled during play and editor. This is going to probably be simpler because we're not tracking a whole bunch of things. We're only tracking the hash name of the shader program, and we are tracking how many references have been added during play and editor, and then removing those at the end. Or more correctly, we'll be calling delete shader for every reference count that has been added by play and editor. And then it will decrement the reference count, confirm that there's still a reference being held, and if there's not, delete it. Cool. So where are we going to do that? Where do we have shader ref count? Here it is. Shader ref count. I will add an element down here. We'll say ifdef. And I've been doing ifdef and ifndef so much that I've decided to just go ahead and make myself a snippet. So I can do this. EP build dynamic. And then we'll do static std map of a hash name to an int. And this will be shader ref counts, or shader refs added during editor play. I guess that makes sense. Yeah. And then when we would increase shader reference count, we would increase the other. Hey Jolo, welcome in. Thanks for your lurk. Cool. Awesome. So in every case where we are adding a shader reference count, we should be adding 1 to shader refs added during editor play, specifically when we are in Plane Editor. So this will be... I'll start by just getting all of the points tracked down where we increase the reference count, and then I will do a Control F on each insertion point, and then I can just copy and paste the code that would conditionalize it for editor play. That'll just be that's just my way of keeping it straight in my head, while kind of reducing my workload. Cool. Shader reference count. Okay, and then here's another one. Yeah, here's another. And here's a few more. And a few more after that. It's the nature of the compilation step that there's actually a whole bunch of situations where I might add a reference count or remove one. So yeah, that's I'm gonna have to hunt down every single place and make sure that I'm adding references correctly. Yeah, here we go. Nearly there, 10 out of 14. Okay, and then we have where we actually go to decrement the reference count. I also need to have decrement to shader refs added during editor play. I'll take care of that in a minute. Yeah, so let's search for... Actually, hang on a second. Yeah, array shader ref count.erase. We need to also do shader refs added during editor play.erase program. And again, I'm going to come back and clean up the conditionalization of these in a minute. Okay, good. Now let's get the boilerplate in there. So we got if def ep build dynamic, and then if runtime is editor and runtime is running. Then we will compile. We will run the code. Awesome. So let me copy that whole section, so that way I can paste it anywhere. And actually, instead of copying all the way to the left, I'm going to use a pro gamer move and copy just the stuff starting on the left edge of the selection. Except for yeah, that's right. Bam, Control C. And in every case where I reference shader refs added during editor play, I'll conditionalize those calls. We'll worry about formatting in a minute. We'll use the auto formatter to take care of this. Oh, that's strange. I'm missing part of the block from above. Okay. I think I know what's happening. So let me redo my copy again. There we go. Now I've got the entire block. Control C on that. View back up. Alright. And then I go to paste. And I can do this. And same thing here. Looks a little ugly at the moment, but that's alright. I am still saving myself time typing, and I will have this cleanly formatted via Clang format in a minute. This still beats having to scroll through a few thousand lines of code and looking and manually typing everything. I wonder if I should make this whole thing a snippet, now that I'm saying that. It might be useful. But, I don't know. I feel like after this task is finished, I won't be using this particular code very often anymore. There we go. Cool. My phone is buzzing at me. I think another celebrity died. Olivia Newton-John died. Oh man. That's too bad. I have to go back and watch Grease. I haven't seen it in a long time. Grease is in that category of movies where I just sort of go a long time without seeing it, and then I forget all the jokes, and then I come back and it's like I have a fresh pair of eyes, watch it over again. There's a few movies where I do that. Grease is one, Spaceballs is another. A lot of Mel Brooks films are like that. I just let it go until I don't have all the lines memorized by heart anymore, and then I decide, okay, it's time to watch it and re-memorize all those things by heart. Okay. Good, I think that's what we need. Let me go ahead and take care of the formatting real quick. So I'm gonna implement a column limit of 120 for this file specifically. Let me at least first make sure that this all compiles. Again, all we're doing right now is we're adding reference counting for the stuff that's added during Play in Editor. What do we got here? Oh, I left the breakpoint in from last time. All right. So it seems to be working still without crashing. I can start and stop and all that just fine. And it compiled into test game, the standalone project as well. So apparently the code that's conditionalized is not affecting the standalone because it's not failing to compile. Cool. All right, and then let's do Alt-Shift-F and apply a Clang format to this whole file. All right. That seems to have done something. But actually, it skipped over several sections that I thought it wouldn't. So like this stuff here. This should be all the way to the left. These should be not not all the way to the left. I guess I'll need to do a little bit of cleanup. That's weird. I wonder why clean format's not yeah, I don't see any output from clean format. I wonder why it's not working correctly. At the very least, the word wrap should be at 120 characters now. Okay, let's just quickly go over those sections. Good, good. Good. Good, good. Well, not quite so good here. Need to tab that over. Yeah, I wonder why clean format's doing that. It's normally right on top of this stuff, but it's messing up this time. This is exactly why I was avoiding doing this by hand the first time, is because I thought that Kling would have my back and do it for me, but yeah, that's really weird. If I use Alt-Shift-F now, it's not gonna break all of the others that I just fixed, right? Yeah, it's like skipping over this section for some reason. Oh my gosh, I know why it's doing that. I know why it's skipping over the section. Okay, whoops. That's on me. I had Kling format comments that turned off formatting within the preprocessor block specifically, so that way when I'm writing code for other sections, it would know to not impose the 90 character limit on them. Yeah, alright. So we're back in business. I remember a really popular expression from back in the 1990s, where like people talking about computers and computer programming, they would just say as a blanket statement, "Oh, computers are never wrong. It's just the programmers that introduce the errors." Like in response to the question, like, what if the computer gets it wrong? There's like, oh, the computer's never going to get it wrong. It's the programmer that's going to get it wrong. And that's kind of correct. And it was correct in this situation, but it's like a huge oversimplification, I think. All right, here we go. I think I am done with this section. Parse include file. Includes in program. Yeah. Okay. That's the preprocessor section cleaned up, I think. Okay. So now that we've got the reference counting all conditionalized for play in editor, I now need to do a few things. I need to track when we try to decrement below 0, when we go to delete the shaders, and we are still in editor play, because I want to alert the developer that they're trying to delete more shaders than they loaded. And then I need to actually go and delete all the shaders that have been loaded, that haven't been deleted yet, when we go to end play in editor. So let's go to delete shaders. So we got the reference counting stuff here. This is the new reference counting here. If build dynamic, and if we're running it in the editor, we decrement that reference count. Now, at this point, we actually do not want to call delete unless or finish with this delete call unless the shader refs is 0 or greater. Yes. So I'm going to need to move this code above the official reference count. So this is the reference counts for everything loaded, including by game systems, which are always running in the editor. And before we do that reference count decrement, we decrement shader refs added during editor play. And we'll say if shader refs added during editor play program is less than or equal to 0, then we need to delete. But actually, this code is a little different. We're going to say if it's less than 0 specifically, meaning that we have attempted to delete a shader more times than we have attempted to load it. Then we know that we need to return early. We need to issue a warning to the developer. So we'll say ep warn graphics delete shader attempted to delete shader program blah 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 more times than it been loaded during editor play, and then pass out the name of the program like so. Okay. And then we need to set the count back to 0. I guess I should say without. Yes. not very well worded. Attempted to decrement reference count to shader program. Blah 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 blah. Maybe the first wording is fine. Yeah. Attempted to delete shader program more times than it had been loaded during editor play. Yeah, that's probably as good as I'm gonna get. So let's leave it. Cool. And then we set the actual count back to 0 and we return. Cool. And then otherwise we will decrement the reference count here. Cool. So now we've got the deletion guard, which was a big reason why we do this. So that way you're not accidentally deleting shader programs that are still in use in the editor. And then let's go down to the cleanup code, this guy. And this is the big reason why we have done all this. So that way when we go to end editor play and you forget to delete all your shader programs, no problem, bro, we got ya. We would say shader refs added during editor play. We would need to say for int I equals 0, I is less than shader refs added during editor play. For each shader. So we'll need to I guess we'll need to go through every key value pair. So we'll use C++ 17 structured bindings with a range-based for loop for this. So we'll do for const auto ref, and then in square braces we'll give the names of the elements. So the key was program, I guess, and then the value was ref count. And we'll set these equal to the, actually we don't set it equal to, we use the colon to say for every. So for every key value pair, program, and ref count in shader refs added during editor play. Whew, that's a mouthful. For every single key value pair, we will call delete. So we'll say delete for int I equals 0, I is less than ref count I plus, we will do delete shader on program. Just like that. So, yeah, and at this point we'll be, all the ref counts will have decreased. The ref count guard is still in place, I believe. Yes, so at this point we won't have to worry about accidentally deleting too many shaders from the cleanup call. And then we can simply clear this whole thing. Shader refs added during editor play. That's going to be completely empty when we've finished. So F7, I think that's working good. It's a cute little dinosaur gif. Cool. And we're back up and running. Everything should work the same as before. Oh, I'm not in the editor. Let me go to the editor. Alright, everything should work exactly the same as before regarding the shader compilation and cleanup. So we stop, and we start over. each time we do this, it's unloading the shaders. However, I was explicitly doing that in my test state. So let's go to teststate.cpp. Let's go to its cleanup code, and instead, instead of calling delete shader inside of my code, I'm going to pretend for a second. I'm going to pretend like I'm an irresponsible developer. And you know, it's looking like I'm going to need to get that Giphy window a little bit bigger because it's cutting off the GIF at the bottom. And I'm going to run just like this because the delete shader call is not being invoked. I'm counting on Enterprise to clean up after me. So I'll hit play and stop. And I've got an assertion. Okay, this is why we do these tests. Retry. Let's see where we're at. Giphy funny. Yeah, I love Giphy. I use it all the time in various chat systems. So I figured I'd set it up here. It's a very work-safe way to get reaction GIFs. There we go. Okay, so what do we got? Shader sampler type identifier OGL is undefined. Wait, that's not the there. That's my watch window. All right, we're in. Okay, so we're in editor play cleanup shaders. We are going through every shader ref added during editor play. There's 3. That doesn't seem right. Is that right? What? Because I thought we had 4 shaders loaded. It must have deleted the first one already. We are still iterating through shader refs added during. Oh, whoops. Okay, yeah, I see what's happening. So what's happening is that when we call delete shader actually goes and clears out shader refs added during editor play. It actually modifies it. So we need to make a copy of it and then iterate through that copy first. Dot. So we'll say auto shader ref copy for the moment. Make sure that this fixes the problem. Let's do shader ref count copy or counts copy, and we'll iterate through that. And then let's confirm that that works. Come on. There we go. And hit F5. And this time, okay, this time it's not crashing. That was key. Now I'm gonna hit play and stop a bajillion times and confirm, because each time I'm doing this, I'm recompiling all the shaders and loading all the shaders again. And now I want to confirm that there is no memory leaks because I'm no longer cleaning up after myself in state.cpp. So let's head back to shaders.cpp. I'll go to the compile call, compile shader source, set a breakpoint on the first line, and then stop and play again. And while we're stopped at this point, we can quickly inspect all of the state memory. Shader reference count 1, shader source paths. Yep, okay. So we don't have a whole bunch of counts for shader references, so the shader references are being decremented. Shader programs has only the one listing for EP null shader. Perfect. Yep, good. I'm seeing only the elements that I was expecting to see here. The includes are being unloaded correctly, because if we take a look at the include source buffers, the only one I have is for enterprise.glsl, which is loaded by the null shader, the magenta debug shader. Yeah, I think we are in the business. I think this is exactly what we wanted. Okay, perfect. And then we continue and. So wait, so I think that shaders cleaned up. All the shader stuff we cared about is now done with. Which, let me confirm. First, let me just take this off of our list. Unload all shaders during project unload. We're done with that now as well. We still have to talk about reloading shaders a little bit. I'll come back to that, but I'm going to minimize it and head back to the resettables list. This was my master list of all the things that I needed to confirm were cleaned up during Planet Editor being finished and the project being unloaded. So we've now done all of this, I believe. Yep. We've done input, we've done events, we've done the time system. We've done the state manager, right? Let me double check. State manager.cpp. We have, state builder, editor play cleanup. It's literally just calling the regular cleanup. That might need to have more code in the future, so I'm still making it its own call. But yeah, the editor cleanup is literally just going through and deleting any states that are still available, that are still inside of the state manager. Which is why when I go to stop, the state gets destroyed, even though I haven't actually done, like if I press escape, then the code actually invokes the destruction, and that's what ends the program. But in this case, I'm killing the program, and that's ending the state. So that's what that's about. So yeah, the last thing then would be scene manager. And this is kind of a tricky topic to deal with. Let me make sure that I've got that formatting working well for my shaders.cpp. And then I will move on to talking about what's so complicated about cleaning up the scene. But you know what's occurring to me right now? There's a test I forgot to do. Let me do that now. I'm gonna do play and editor on and off a bajillion times. So we got play and editor working. I haven't actually tried unloading the project yet. So let's say close project. Okay, that seems to be fine. It seems to have worked fine. Let me reopen the project, hit play. Okay, that seems to be working. We still have some scene issues like this where Madeline is now overlapping Hollow Knight, but we'll come back to that. This still seems to be functional though without crashing, and we know that the cleanup code was all... the cleanup code for ending the project was all based on the cleanup code for ending the play and editor. Oh yeah, you know what? Hang on. Shaders.cpp, cleanup. Where's cleanup? Here, cleanup shaders. Yeah, I have forgotten a few things that are very, very important. Let's deal with that now. Inside of the delete shaders call, here, I added a couple of things that we needed to clean up that turned out to be bugs. We need to erase the contents of shader sampler type and shader sampler locations. We also need to... There was another couple of things. I tell you what, I'm going to put a to-do note down here, and I'll just review this. This is going to be very dry work. I'm going to review this before I commit the code. So I'll say, under cleanup shaders, I'll say to-do compare this code against delete shader. Because I want to make sure that we're cleaning up the last couple of things that we had to clean up here. And I'll probably do some profiling as well. Yeah, make sure that we have no memory leaks. But yeah, anyway, let me do Alt-Shift-F and reformat the whole file using claim format. Again, we are using 120 characters for this file specifically. And that seems to be looking all right. Then I'm going to be heading back up to the top of the pre-processing code block. This 2,000 line monstrosity. And actually, should I go farther than that? Yeah, I need to do both parse include file and there we go, and compile shader source. I need to reinsert the cling format off and cling format on comments. God, this is a lot of code. And here, compile shader source, yeah. So below compile shader source, I need to have cling format off, or on. There we go. And the reason why I did that is because now I can set column limit back to 90 and save that. And when I do Alt-Shift-F, it will format everywhere else besides these two specific methods. It'll format all of them to be 90 character widths, which is what I want. Okay, that's good. And let's F7 and make sure I didn't break something. Oof. Come on, any moment. There we go. That seems to be all up and running again. Alright, so the last thing to talk about is the scenes. And I'm unsure whether I want to do that on stream today. I've been going for 3 hours almost. But I figured it'd be worth at least talking about what's going to happen next. So, with all of the other systems, input, graphics, and all of that, it's pretty straightforward to determine what needs to be reloaded and what doesn't. Because in those cases, we can simply track what's added during play in editor. So in other words, what's added from your game state code versus what's added from your systems. In the case of the scene editor, it's a little bit more messy. And the reason why is because of this tab that we haven't done anything with yet. Anybody who's used a game engine editor like Unity or Unreal knows that one of the entire point of these editors basically is to be able to construct scene files. You need to be able to place and edit objects in the game so that you can play. You can come up with levels and other content that will be loaded at the game at runtime. And in the case of Enterprise's scene editor, we have a slightly more complicated version of that. We are now talking about every single game extending or modifying that system. So in the case of this little demo we've got going here, there's a couple of different elements. The text in the middle and the text on the upper right hand corner, that is not part of the scene. It may look like it's inside the scene, but that's only because I am rendering using the camera stack. I have the ability to place things in the scene or take them completely out of the scene when I go to render something from code versus rendering a scene, if that makes sense. And I don't think I have testing on either, so if the text goes over Madeline here, for example, yeah, the text goes over the top. That's unrelated, technically speaking, but I probably would have depth testing enabled before I render something like this. Anyway, Madeline and Hollow Knight, though, these two sprites in the scene, they are rendered from a scene file. I do actually have scene files working. Let's open up the test scene, or test2dscene.yaml. This is the file containing. This is the file containing the sprites and their components. So this is the way that it works right now. We have a YAML file that basically just has nodes for each thing. There's an entities node and a components node at the root level. I don't think I need to have others. Maybe if I have like scene properties or something, I'll add another base node, but for now it's just the entities and their components. The entities section is populated entirely by Enterprise. This is data that's universal to any game that might use this engine. And the keys inside of this node, because we have key value pairs here, the keys are identifiers, unique identifiers for these entities. So I just typed in some random numbers here, 1, 2, 3, 4, 5, 6, and this 1, 5, 9, whatever. And this represents sprite 1 and sprite 3, and then I have some commented out stuff for sprite 2 and sprite 3. Basically, these are just the string name of the entity, so what should appear inside of the editor, and inside of error messages, I suppose. The position, XYZ location of the entity. A rotation, which is a quaternion in this case, Y, X, W, and Z for the 4 elements of a quaternion. And then the scale, which is a 3D scale in model space. So in this case, sprite 1 is scaled up 2 times as big on each of the dimensions. And technically speaking, the Z dimension doesn't matter here because all of the points are on the flat plane. But if you have a 3D object, you can scale the 3 axes independently. That's the point of this. And then when we look inside of the component section, we have a corresponding key value pair for these IDs. So this structure was chosen to make it extensible. In the case of my test scene here, or my test game, I have a renderer 2D system loaded. If we go to testgame.cpp, we can see that. In GameSysInit, I call renderer 2D init, and I give it a value of 1,000. And that's just to say, here's the maximum number of sprites I want a scene to be able to handle. And renderer 2D uses that to allocate a pool, so that way whenever you go to instantiate another sprite, it will not have to allocate it. It'll just grab it from the pool. It's a pretty common memory trick in game engines. Voice is getting a little raw. All right. Now, inside of the scene file, when you initialize a system, that it means to extend that file. If we take a look at the renderer 2D's initialize call, it does all of its internal stuff. So on the internal side, it manages its own memory for its stuff. And in this case, we manage pools, basically, of the data that we need to track. And then once we have all the memory and all the resources needed for renderer 2D figured out, we then register the system with Scene Manager. Scene Manager is not just for updating the entities, it is also for updating the systems. So we start by registering Scene Manager register scene draw function, passing in the scene draw member function of renderer 2D. And it's really simple in this case. We just invoke draw sprite components, which does all the work. But we basically with this code hook, we're telling Scene Manager that every time it's time to draw the scene, and we don't care who is drawing the scene, I want to extend that by rendering onto the current frame buffer. So the idea is that you can even have other systems draw the scene, and those other systems will get the output of this system, if that makes sense. Because any place that calls Scene Manager draw scene, that will invoke scene draw because we registered that call. And this allows you to make an entire rendering pipeline for rendering the scene, and then make a pipeline on top of that for rendering, or for deciding when to render the scene and where and how to use it. So yeah, this is a pretty flexible piece. So we register the scene draw function, and then we register the component type. And when we do that, we pass in the hash name of the component type, which is sprite. We pass in delete sprite component, get entities with sprite components, serialize sprite component, and deserialize sprite component, which are all function pointers to the memory management stuff. So we're essentially what we're doing is we're telling Scene Manager, hey, I want to register a component type, and we're going to add this to the editor. We're going to add this to the game, and we're going to add this to the scene files. And Enterprise goes, okay, well, what do you want to call it? And I say, I'm going to call it sprite. It's the name of the component. And then it asks, okay, what do you want me to do when we go to delete this component? What do you want me to do when we want to serialize this component? And we basically pass in functions that handle all of those things. Now, this is something that's probably going to change a little bit as we go forward. But the result of this is that when we go to load a scene file, a node is added to the components section for this component. So we have components, and then the first key underneath it is sprite, representing that this block contains all of the component information for this component type. And then if we go to serialize and deserialize, the renderer 2D system can basically is just past that node. It's past that block of information and says, okay, do whatever you want with it. And so the renderer 2D is actually defining what the format of the contents of this section is. And I think that's going to be really flexible, because you don't know, like I don't know all the different ways that you might want to serialize data into your scenes. If you have a very custom system that you have to serialize something very specific and special and unique to your game, basically I'd say, okay, here's the data where you can serialize it. Go to town, you just write anything you want out here and then use it. So in the case of renderer 2D, we basically take and when we go to deserialize, we look for path, we look for UVs and min filter, and inside of here, we associate each with a particular component. So we have the ID 1, 2, 3, 4, 5, 6. That means that this sprite component is attached to this entity, and these are its details. We are loading up texture 1. We're using these UVs, 0, 1, 0, 1, meaning just going in a circle around the size of the texture. We're using nearest point filtering, and we are not using bitmaps. Yeah, so all of this stuff is serialized. Now, coming back to the scene, this gets a little complicated because play in editor is pretty much going to let the editor load the scene. The idea is that you are developing a scene in the editor, like you're designing a level, for example, like platforming obstacles or whatever. And then when you click play, all play does is it sets up the gameplay conditions. So things like the game state that handles your input, handles your Xbox controller or whatever. And then it just kind of lets the scene simulate. So I'm going to need to transition from doing it this way, from loading up everything from the test scene, and actually have the editor itself directly load the scene file, and then we play on top of that. And that's going to be fun. I think that's what I'm going to start with tomorrow. But it's also going to be a lot of work, so I don't think that I'm going to start that part today. So I'll need to have a scene going, or a game state going where I can test play in editor. So I'll have to come up with some interesting ways to interact. Maybe I'll start with like very basic platforming game code, where I've got like a sprite that's your character, and then then the character like falls and whatever. And then I'll have to add rudimentary collision system. I'll have to add a number of systems in order to get to the point where the level editor can be robustly tested. I'll do some of that offline, but for now, I think I'm just gonna wrap it up and do the other stuff I got to do today. But yeah, we made progress. I think this is the last time. Yeah, I think we're officially, with the exception of some of the quirks related to scene managers cleanup, which kind of directly ties into setting up scenes to work in the editor. We've actually got everything cleaned up that needs to be cleaned up when you go to start and stop play in editor. So at this point, I should not be able to crash anything by using start and stop and reload and all that. I'm gonna just quickly play with this a few more times and confirm that everything is working okay. Yeah, sweet. So just not getting the application to crash is a big step, and to do it without memory leaks is really important. And I think we're at a state where we can start building the other stuff. Cool. Thanks for joining me. I'm gonna take off and come back tomorrow, and tomorrow we're gonna start in on actually doing scene editing stuff in the editor. That's gonna be cool. That's gonna make this engine feel like it's an engine, instead of just a little test graphics thing. All right. Thanks for joining me. Talk to you later.